This is key to worksheet number 6 on radicals. And again, we're dealing with square roots. Now, in this case, you want to divide, and notice that your denominators contain square roots. So remember, you don't want any of your answers having a square root in the denominator. So that's why it's going to say rationalize the denominator. So basically, if it's just a real number, rationalize the denominator means make it a rational number. Here we have an x here, so rationalize the denominator here would mean don't have a square root in the denominator, basically. All right. So let's just look at how to deal with this. So in number 1, and it's not really a bad, it's not hard to understand. It's a fairly easy concept. So in number 1, we have 2 divided by the square root of 13. So square root of 13 is an irrational number. I want to make it rational. I want to make the denominator rational. So one way to do that is to multiply both numerator and denominator by that square root of 13. Okay, and remember, what you do to the denominator, you do to the numerator, because you want this to be a factor of 1. And so now what I have is 2 in the numerator. I have 2 square root of 13 divided by, and then if you need to, write out this step, the square root of 13 times square root of 13 using a product rule. That's going to be the square root of, and then use your calculator, 13 times 13, if you need to. 13 times 13 is 169, right? Now 169, see how these are the same radicand? So this should now be a perfect square. And the square root of 169, if you use your calculator, is just 13. So we get 2 square root of 13 and divided by 13, and notice that 13 is now a rational number. So just make sure that the denominator does not have a square root in it. It's okay for the numerator to have a square root, but not the denominator. All right. So now I just want to be clear. We rationalized the number. We made the denominator a rational number, but still, this number here is still irrational because it has a irrational number in it. So if that square root of 13 wasn't there, then 2 13ths is rational. But since I have an irrational number, it makes the whole thing irrational. All right, but the denominator is still a rational number. The whole thing is irrational. So when you rationalize the denominator, all it means is just make the denominator, rewrite the denominator so that way it doesn't have a square root in it. All right, number 2. Number 2, we have 15 divided by the square root of 50. Okay, now, there are a couple of ways that I've seen students do this. So students will do just like we did this. They'll say, well, I'm just going to go ahead and multiply the denominator and numerator by the square root of 50. All right, there's nothing wrong with that. You can do that. So I get 15 times the square root of 50. And then most of you know that 50, the square root of 50 and the square root of 50 is just 50. But if you did not, and you have to do it like this, then that's fine. So you're going to say 50 times 50, 50 times 50 is 2,500. So we get the square root of 2,500. But you got to recognize, though, that 2,500 is a perfect square because you said 50 times 50. And so when you multiply a whole number times itself, that's a perfect square. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 10 times 10 is 100. Those are all perfect squares. 50 times 50 is 2,500. 2,500 is a perfect square. So if you took the square root of that, I just rewrote the numerator. If you took the square root of that, you're going to get 50 back. But here's the problem, though. You want your final answer to be simplified. Okay, you want to make sure that you simplify your answers. So if you look at the square root of 50, I can still simplify the square root of 50. And also, I can reduce the 15/50ths. But let's talk about the square root of 50 for right now. Let's talk about the square root of 50. So go off to the side and do that. What perfect square goes into 50? Well, that'll be 25. So it'll be square root of 25 times the square root of 2, right? And the square root of 25 is 5, so you get 5 square root of 2. So that's going to be this part right here. So notice what I'm doing. I'm rewriting this as 15 times 5 square root of 2 divided by 50. And now let's reduce. 5 will go into 5 one time. 5 goes into 50 10 times, right? and I can still reduce the 15/10. They're both divisible by 5, so it'll be 2, and that's going to be 3. And so then I get 3 times 1 times the square root of 2 divided by 2. So 3 square root of 2 divided by 2. All right, so that's the answer to number 2. Okay, so that's answer number 2. So let me write the answer here. Number 1, the answer was what? 2 square root of 13 divided by 13. Number 2, we have 3 square root of 2 divided by 2. All right. Okay, now number 3, we have this. We have the square root of 7/11. Notice that the radicand is 7 divided by 11. So we can use the quotient rule, first of all, to rewrite it like something like this. So it'll be the square root of 7 divided by the square root of 11. Oh, I want to go back. I'm so sorry. I want to go back and I want to tell you the way that some other people would do number 2. Excuse me. I forgot to do that. So let's go back to number 2. So number 2, we have 15 divided by square root of 50, right? What some students will do first is they will simplify the square root of 50 first. Okay, let's do that. So the square root of 50, and we already know that the square root of 50 is 5 square root of 2. So they're going to rewrite this as 15 divided by 5 square root of 2, correct? And remember, all you got to do now is just rewrite this so that way you don't have a square root of 2 in the denominator, that this is no longer a square root. So that 5 wasn't there, wouldn't you, and let me go ahead and rewrite this. Wouldn't you just multiply, that 5 wasn't there, wouldn't you just multiply both numerator and denominator by the square root of 2? Well, that's all you do. And so notice my numerator is 15 square root of 2, and my denominator is 5, and then square root of 2, then square root of 2 is square root of 4. And so I get 15 square root of 2 divided by 5 times 2, right? And then reducing these, 15 and 5, I get 3 square root of 2 divided by 1 times 2 is 2. All right, so you get the same thing. So it doesn't matter. It doesn't matter if you don't reduce first, but you would have to reduce to the end. You would have to simplify the end. Okay? All right, so I forgot to mention that. All right, so number 3, let's go about number 3 now. You have the square root of 7 divided by 11, so it'll be the square root of 7 divided by the square root of 11. And notice that so you may say, well, in number 3, can I work on number 2? Well, the problem is that the number 2, I could have simplified the square root of 50. And number 11, I can't. The only perfect square that goes in 11 is 1. So all you can do now is just say, well, I need to rewrite this so that way the denominator is not a square root. So I'm going to multiply numerator and the denominator by itself, by that denominator. And so using a product rule, what you notice is the square root of 7 times the square root of 11 is the square root of 77. Okay? And then square root of 11, square root of 11, I need for you to understand now that square root of 11, square root of 11 is just 11. Because remember, the square root of 11 times the square root of 11, if you actually work it out, 11 times 11 is 121. And remember, since these radicands are the same, this radicand is now a perfect square. So the square root of 11, the square root of 121 is going to be 11, that radicand. And so there's your answer. You're done. You cannot simplify the square root of 77. All right, so number 3, the answer is square root of 77 divided by 11. All right, let's talk about number 4. So number 4, we have the square root of 15 divided by x. And so using the quotient rule, I can rewrite this as the square root of 15 divided by the square root of x. And again, now this time I have a variable instead of just a real number. So we're going to do the same thing. So to get this denominator to not have a square root, we're going to multiply numerator and denominator by this denominator. So square root of x, square root of x. Now, let's talk about the numerator. The square root of 15 times the square root of x, using a product rule, is the square root of 15x divided by. And then the square root of x and the square root of x, remember the square root of x times the square root of x is the square root of x squared, which we all know is just x. And there's your answer. Now again, you got to ask yourself, can it simplify the square root of 15? No. Can it simplify the square root of x? No. And remember, the reason is because the exponent 1 is less than 2. And the only perfect square that goes in 15 is 1. So there's your answer. So the answer number 4 is square root of 15x divided by x. All right, let's go to number 5. Number 5, we have the square root of 5x divided by 7. Now again, using a quotient rule, I'm going to rewrite this to where I have a numerator and I have a specific denominator. But notice that I have a square root here, so this is irrational. And so I need to get rid of that square root. So one way to get rid of the square root is to multiply numerator and denominator by that denominator. All right, so let's talk about the denominator first. I need for you to understand that the square root of 7 times the square root of 7 is what number? 7, right? Because remember, 7 times 7 is 49. That's a perfect square. And the square root of 49 is just 7. So it's just this radicand. Now the numerator, I'm going to use a product rule. 5, remember what that means. The square root of 5x times square root of 7, I can write as one square root. So the square root of 5 times 7 times x, right? And so that's the square root of 35x. And then ask yourself, can I simplify that square root any further? What's the only perfect square that goes into 35? 1. And then notice the square root of x, since the exponent here is 1, 1 is less than 2, I cannot simplify that. So that's your answer. So the answer number 5 is square root of 35x divided by 7. Square root of 35x divided by 7. And make sure the x looks like it's under the square root. Okay, number 6. You have 8x divided by square root of 2. So same thing. I cannot simplify the square root of 2, so I'm going to go directly and just multiply both numerator and denominator by the square root of 2. So that should get that should now make the denominator. Once I do this, that should now make this denominator a rational number. So notice though, in the numerator I get 8x square root of 2. In the denominator, what's the square root of 2 times square root of 2? Tell me right away. 2. But you can simplify further because the 8 and 2 I can reduce. So 2 and 2 is 1. 2 and 8 is 4. So the answer is 4x square root of 2. That's the answer. So 4x square root of 2. All right, number 7. All right, so number 7. So now number 7, we have this. We have the square root of x to the 7th divided by 5. All right, using a quotient rule, I can write this as the square root of x to the 7th divided by the square root of 5. Okay? All right, now notice right away I can do several things if I want to. I can simplify the square root of x to the 7th first, which we know we can simplify because that exponent is greater than or equal to the index. Or I can just go ahead and rationalize the denominator first. Let's go ahead and rationalize the denominator first. So it'll be the square root of 5, square root of 5. So you're going to multiply numerator and denominator by the square root of 5. And so then I get, writing this as 1 square root. I'm going to get the square root of 5x to the 7, just like that. And then divided by, tell me right away what this is. Square root of 5, square root of 5 is square root of 25, which is what? 5. All right, now let's talk about the numerator. Let's go off the side and deal with the numerator. So just like we did before, so I got to simplify this. So do y'all agree that using a product rule, this right here becomes the square root of 5 times the square root of x to the 7th? And then I cannot simplify the square root of 5, so I'm going to leave this alone, but I can simplify the square root of x to the 7th because the largest even exponent less than 7 is 6. I can write this as square root of 5 times the square root of x to the 6th times the square root of x. And then notice that I get the square root of 5, and the square root of x to the 6th is x to the 3rd power times the square root of x. And so now I'm going to write this as one radical. And let's put this in front, though. So it'll be x cubed times the square root of 5x. 5 times x is 5x, the square root of 5x. So that's going to be up here. So it'll be x cubed times the square root of 5x. Make sure 5x is listed. You can tell it's a radicand divided by 5. And so that's the answer to number 7. So x cubed, square root of 5x, divided by 5. All right, and then number 8, we have this, number 8. We have we have the square root of y divided by 18x. And so according to the quotient rule, I can write this as the square root of y divided by the square root of 18x. All right, now, just like we did in number, I think it was what, number 2? So if you don't want to simplify the denominator first, you can go ahead and multiply both numerator and denominator with the denominator to rationalize that denominator and then go from there. Or you can, like we did here, you can simplify the square root first and then rationalize, and then you can go from there. Does not matter. That's the situation we have here, because I want you to notice that the square root of 18, I can simplify. That's the square root of 9 times the square root of 2. And so the square root of 9 is 3, so you got 3 square root of 2. Okay? So the square root of 18x then would be 3 times the square root of 2 times the square root of x. And so that's 3 square root of 2x. Okay? So that's one approach. So let's go ahead and do that one first. So what I'm going to do now is just I'm going to rewrite this as 3 square root of 2x. So this is this. Now, if that 3 wasn't there, let's say that 3 wasn't there, then to get rid of the square root, you would multiply both numerator and denominator by the square root of 2x, right? All right, that's what you would do. Okay, so let's use the product rule here. Do y'all agree that the square root of y times the square root of 2x is the square root of 2xy? All right, now let's talk about this. Now be careful. If the 3 wasn't there, so if you cover up the 3, what's the square root of 2x times the square root of 2x? Remember, like we've been doing before, what's the square root of 11 times the square root of 11? 11. What's the square root of 7? Square root of 7? 7. So whenever the radicands are the same, oh, and by the way, square root of x and square root of x is just x, right? So whenever the radicands are the same, you're multiplying square roots, it's just that radicand. It's just that radicand. It's just that radicand. So here, what do you think it is? Square root of 2x plus square root of 2x is just what? 2x. So this becomes 3, though, times 2x. Okay? Now, if you needed to work it out, then work it out. So here's what we have. We have the square root of 2x times the square root of 2x. Well, according to the product rule, that's going to be the square root of 2 times 2 is 4, and x times x is x squared. And then notice, using the product rule again, we get the square root of 4 times the square root of x squared, which is 2x. Okay? So, and then one thing we need to do now is just multiply the 3 and the 2 together, and that should be the answer. The square root of 2xy divided by 6x. And I cannot simplify the square root of 2, I cannot simplify the square root of x, and I cannot simplify the square root of y. So there's the answer. Okay? Now, if I wanted to do it the other way, so here's another way you could have done this without simplifying the denominator first. You could have said this. So watch. So let me go ahead and rewrite this right here. So it'll be the square root of y times the square root of 18x. So right away I can multiply both numerator and denominator by the denominator, and that will, since that's the square root, that will make this an expression without a square root. So I get using a product rule in the numerator, I get the square root of 18xy divided by, and then just like we had our discussion a while ago, what's the square root of 18x and the square root of 18x? It's what? 18x. But if you need to work it out, you work it out. The square root of 18x times the square root of 18x. 18 times 18, use your calculator. 18 times 18 is 324. And then x times x is x squared. Now, using a product rule again, I get the square root of 324 times the square root of x squared. Now, remember, 18 times 18, that product is a perfect square, because that's how we get perfect squares. We multiply a whole number times itself. And so the square root of 324, if you use your calculator, you should get the 18 back as your answer. So the square root of 324, I get 18. So this will be 18, and the square root of x squared is x, and so that's what this is. Okay? But here's the answer. Don't leave it like this, though. Some of you will, because you're going to forget to ask yourself, can I simplify the square root of 18? And the answer is yes. I can simplify the square root of 18. I cannot simplify the square root of x, and I cannot simplify the square root of y. But here's the thing. See where I had that numerator? So that, using a product rule, that's going to be the square root of 18 times the square root of xy. I'm going to leave that as xy because I know I cannot simplify that. But I can simplify the square root of 18. Square root of 18 can be written as the square root of 9 times the square root of 2, and then the square root of xy. And then square root of 9 is 3, so you get 3 square root of 2 square root of xy. And then rewriting this as one square root, using a product rule for square roots, I get 3 times the square root of 2xy, and that goes here. So it'll be 3 square root of 2xy divided by 18x. Now you can simplify this to 3 and 18. So 3 and 3 is 1, 3 and 18 is 6, and so I get the square root of 2xy divided by 6x, which is what we had here. Okay? So again, it doesn't matter which approach you take, you will get the same answer in the end, though. All right? So that is number 8. So number 8, we have the square root of 2xy divided by 6x. All right, so that is the key to worksheet number 6, where you get to rationalize the denominator. All right, so that's the answer. I mean, that's the key to number 6.